Welcome everyone. Today we're going to talk about simplifying network orchestration and the architecture challenges and state of the art about this topic. My name is Ariel Ligouri. I'm a network architect, an engineer with background in telco and enterprise, currently working as VP of Software Defined Networking at JPMC. The agenda for today is we're going to talk about the problem statement around orchestration and automation, how we actually traverse all that path from the first day to the current state of the automation, and then the architectural decisions that you should consider in order to simplify your network orchestration strategy, even if it's a third party or homegrown development. I think we all know why we need automation or orchestration, right? At the very beginning, it was mostly focused on automation, automating the things that we do, starting with human processes and then using software tools to actually get rid of the issues that we have, which are essentially a diverse ecosystems of domains, network devices that can go from optical to data center. And of course, when you talk about different silos, right, you are also talking about different teams supporting those specific environments. I always recall the lack of a single lingo. That is that when you talk with an optical guy and then you go to talk with a data center one or a network backbone, right? They all talk in different terms. They have their own lingo, but none of those is the one that the end user actually uses. So you have to do that translation from each level in order to them to get to the real use case that the customer is actually requesting you. The problem that we also raise is that it is not being user driven. That is that the end user has no impact towards the whole topology in all the multi-domain approach that you might have. And the intent that this end user is actually pushing, it gets lost into the chain of domains that you might have. So what was the first approach that we took? So it was automation. Automation has the savior because we all know it can reduce time, avoid human errors, and reduce costs. This actually sounds great, but is this really enough? So let's take a close look. So we have automation, and we all know the beauty things that we have, right? But what about the hidden costs? The not so funny part of the story, right? So you will have development costs, huge investment to actually to make your current networking devices or domains to actually support these kind of automations. Let's say that you have very old network legacy gear that it don't even have an API, right? You have to work something and write something on top of it. And of course, the human errors are now being translated into bug fixes that you have to do. So it's pretty much like a translation from one model of code to other. And we can argue that it is all going to reduce your time to market, which is at the very end, your end goal. When we move from automation, we start what I call the second wave, which is orchestration has the panacea. So in the orchestration, we took care about integrating all those automation silos that we have. And of course that here standards plays a huge role because if you have multiple domains talking each other's, is there any domain following standards? How they are going to actually to converge in that single lingo that I talked at the very beginning? Orchestration is actually the one that is going to give you a view which is end to end. It's going to give you tracking about the order state across the whole change, and it's going to provide this translation from one domain to the other. So the optical guy, when it ends his stuff, it will let the network backbone guy that he can configure the other part, right? And so on. Data center, application team, till the very resource that the end user has requested. So is orchestration the unicorn that we were looking for? Let's take again a nice review. So we introduce now the concept of end-to-end automation, and of course, standards driven. But we also have some downsides, right? We have the integration costs. And how many standards do you believe that there are today in the industry? At the very moment that this second wave started, right, there was not so much alignment between all the standards. There were so many in some fields, and there were a lack of in other areas, right? So today we are going to face a different approach because most of those standards are converging. There is an alignment process between them, and that's a good stuff for sure. Then we have what I like to highlight, that is the target state, maybe not the current one, right? Which is intent driven. We all know we want the end user to declare what they want, right? And it should be end to end, and it should be capable to satisfy this intent across all the chain with no change from their side, right? They are just requesting their desire. It's going to be based on declarative consumption. So this is pretty much exposed to what I call the DevOps guys from today, the ones that are used to consume infrastructure as they were developers, which is going to be decoupled from your business model because you can go and directly consume the infrastructure itself, but it will retro feedback your business at the very end because you have to bill for it. And of course, it relies heavily on standards. If you want to reach this target state of automation with all domains being capable to talk each other, a rely on standard is really needed. Finally, the last part of the ICE review for the target state, we can argue that we are going to be declarative and intent driven now. But then we have to adapt all of our work towards the orchestration and automation silos that we have to actually to be able to reconcile, which is essentially rollback capabilities and the ability to fulfill an intent. Is you have your desired state, you have to go for it, right? And you have to manage the drift that it might arise from your current state to your desired one. That's what I call a reconciler adapter. And then, of course, for this self-healing and the intent fulfillment, you need a sort of tracking about the current state against the desired state, against the intent, and take some actions on it, right? And here is where AI and ML starts. But this has some other issues that we might discuss here on other debates that we have across this conference, which is what we call the AM and ML bias. Now let's go to the second part. So if you want to actually simplify orchestration, you can follow an architecture point of view. You have to pretty much came up with a vendor or homegrown your development. And I like to think that if you ask a group of engineers to make a system that is going to actually to fulfill these issues that we were just describing, they're going to come up with this architecture design decision and considerations across all the different areas that we're going to focus on. So which design considerations are like the pillar for all the architecture that is going to fulfill your whole automation / orchestration strategy? So we talk about a common lingo. So that is standard-based and interdomain across all the orchestration system that you may have. And this introduces something very important. You will not have a single high layer super orchestration, right? You essentially will have different silos. That's something that always happens. You will have controllers on top of them, and you might have different orchestration system for each of them. But guess what? They have to talk. They will rely on standards as much as possible, and we always have to push for standard-based solutions if there is no one, right? There's a lot of initiatives like Etsy and ONAP today being aligned to provide you this, and there is a lot of things still to do, like MEF, open service broker APIs, to expose to the billing system and the end user consuming systems. So that's the first one, right? They need to talk in the same language. And something else important is that language, it should be easily translated from what the end user is actually requesting. Then we have like common considerations, no single point of failure. So any networking guy will know that one, right? But here, when you're writing a system, and this system is comprised of multiple controllers, multiple orchestration that they need to talk each other, you will end up with multiple distributed systems that they need to talk each other. It's going to get very, very complex, and you need to design it properly. So, and the whole point on distributing them is actually to reduce what we call the blast radius, the issue that you can arise when one of the failures happens, how it will affect the rest of your main domain. It has to be scalable. So now we're talking about multiple domains being interconnected. So those domains, it might be from the same area, right? So you will end up, let's say, with multiple layers of controllers in one single domain, like data center. Yeah, you have multiple locations. So how you decide which one to reach? Are these domains going to be interconnected, or you are going to handle all of them separately? So that will impact your scale abilities, and you are going to hit some limits when you try to actually to connect all of them at the same time. So designing in a federated way is a smart choice for sure. Again, intent-driven reinforcement about the intent that you have, and tracking and measurement is key in order to satisfy the intent. We talk about multi-domain, and I quickly briefly say about single controller versus multiple controller. So single controller is beauty, but it's not going to scale, right? You will have multiple diseases in multiple locations, and they're going to have their own unique resources. So, but multiple controller approach, how do you identify which target domain to actually to consume, or which controller to consume? So this is the way to go, but you have to realize some sort of mechanisms that actually advertise out which resources are being placed at a very specific controller layer or controller domain, right? This sounds silly, but when you have cloud native apps that can migrate across different regions and availability zones, you will end up by having an application spread across the globe. And if you have to apply something just to that specific app, like a QoS or some policy to the app layer, which is how the user talk, right? They talk about intent against the app, not against a PC or an IP address. So you will need to identify those domains. So multiple domains is a great choice, but it will make you to actually to develop some systems auxiliary for them to actually due to the lack of these advertisement capabilities that you will need to sort out, right? The challenge here again is the resource advertisement and the scalability. Then we have the execution model. I like to think that you have the controller layer, and I remember this on-app or Etsy diagram when you have your OSS, BSS layer, then you have the northbound APIs, right, the MBIs, and then you have the controller layer, and then the SBI talking to the end devices, right? And I call this last part the one that is talking with the end domains, or the last part of the infrastructure using the SBI has the execution layer. This execution layer, it should not be coupled into the controller. It should be as stateless as possible, because that will give you the ability to actually to scale in terms of different execution layers. And it will be decoupled from the controller itself. So you can scale with not need to actually to have in the controller. So whenever you can decouple from the controller, it will be great. So telemetry plays a crucial role here. We're all talking about intent. So if we're talking about intent, why is that, right? And this all came back to an SLA agreement with your end user. So SLA is always too simple rhythm. But if we're going towards an intent-driven model, we start to enhance that, right? And say, okay, you will have QoS on this app, which essentially means this availability and this amount of traffic being reserved and so on, right? But how we actually fulfill, what are the KPIs that we measure? So telemetry is playing here the crucial role. you have to track all the intent across the chain, that is multiple domains, ensure that the intent is being fulfilled, and if not, acting, right? And how to get this data, will depend, of course, on your domain, but how you process it, it will actually have some architecture impacts. So if you want to do a pub-sub patterns or observer ones, right? Essentially, if you want to subscribe to the intent or the telemetry bus, or you want to have an approach which is actually always constantly looking and be aware of all the points that are towards your data model. Of course, the latest one is not as scalable as the first one. If you ask me, there is use cases for both of them, but in distributed systems, you will end likely with publish and subscribe pattern. We will cover patterns, by the way, in one of the last slides. Security aspects are very, very important as well. So we have intent driven for the resources, but we have also intent policy that we want to apply. And this is again, user driven, not against an IP. You don't want to firewall your DMZ or to firewall your specific IP address that is being NAT. You want to actually to secure your application and allow the application A to talk with application B within your domain. So that is what I call the policy intent. And here again, in the chain, you have multiple domains. Those multiple domains may have different policy enforcement points, and you will have to talk across all of them with what I call a policy engine layer that is going to define and say, okay, go and touch all these points in the security chain that you have just asked. And of course, the intent fulfillment is going to translate to policy distribution and intent compliance in this case. Finally, which patterns you should consider when you are going toward this direction of writing your own architecture or taking a third-party vendor, right? So what I will always say that it's much bigger than a pattern itself. It's the convention over configuration approach, which is like a paradigm, right? So don't take decisions that don't really need to be taken, right? It is be taken by any other, so like a config, so let's use it, right? This will save you a lot of time. Then we have the specific about intent fulfillment, which I call reconciler pattern, which is going to actually always try to push your desired state. And then memento, which is for other domains which are not really intent driven, but you have to say, let's provide a rollback capability, right? You will face that you will have devices that are not able to actually to satisfy an intent. They are not infrastructure as code ready, right? So you have to write that, and memento is a good pattern for it, right? So remember your last state, and if something should go wrong, okay, let's go back. So facade is going to be a key here because we all talk about multiple silos. So guess what? All those multiple silos, they have different API layers, but you have to expose only one. A standard base, if you ask me, right? That will be key. And you have to write a proxy to actually to talk this API layer, northbound, and some custom different API towards the downside silos. And then pops up a pattern, what I briefly talked about. If you have to actually to inform a lot of folks, you can follow observer, but that will not scale when you have multiple regions, multiple domain, multiple infrastructure devices. It is not going to scale. It's just simply not, right? But what if you go towards the other path? You will have someone that are going to publish the content, and whoever is interested on it, it will just subscribe. Like the old XML, RSS that we all know, it is pretty much the same. And finally, one term that a colleague came up with is being AnyDayOps ready. That is, we are all used to actually to create stuff and build code actually to the build deployment day one. And then we focus on how we support day two. And the concept here is don't focus on day one versus day two ops, right? Just write it once, and that should be idempotent and be able to be used multiple times. That is intent driven from the very, very beginning. And that will give you the ability to use your same approach at any day. That's why we call the AnyDayOps, which is really, really based on reconciler pattern and idempotency. Finally, integrations, pretty much like a wrap up to what we should say. So REST APIs for the internal and external access. For external, pretty much alike with some standards, MEF, TMF, OSB APIs. The MBI with your different controllers, there is a lot of work being done there since a lot of years. You heard me past year in this same conference talking about NFV SOL 005, and today we have pretty much the same standards being evolved. And SBI, multiple layers of devices, they're converging on different standard approach. You can follow OpenConfig, you can follow any of the other standards. That will be good. The important thing here is that your execution layer, you will always be decoupled of your controller layer. So you can scale, you can include different SBIs in the future if you need to. And finally, we reach the lifecycle management, which is like the fourth wave challenge that we are going to have, right? We have this automation orchestrated across multiple silos, and then we have to actually take a view and a holistic view from a single point, right? And we actually want to fulfill the intent gracefully across all the domains, which is going to be based on AA and ML. And of course, this introduced like the ability to actually to came up with what if scenarios across multiple domains, failures or changes, let's call it. And it is really the challenge that we're going to face toward what is coming in the future, right? And this is like a quick sum of what I consider that it will be helpful for you to consider when you are architecting this kind of devices and solutions. Let's say we are not building anymore like a single controller or a single orchestration. We are creating a huge distributed system which is actually conformed with multiple distributed systems at the same time. Each of them focus on a very specific domain, but all of them need to talk each other to fulfill the intent that the end user is pushing. And that's the key here. So thank you so much, everyone. And if you have any questions, you can follow in the Q&A that is here in the conference slide, or you can ping me directly outside. Thank you so much.